purpose of this lab was to carry out 5 reactions of copper and record observations of resulting products through a video.
Massing the weigh dish, we massed about 0.500 grams of light copper turnings to the nearest 0.0001 grams.
Next, we placed the measured copper turnings in a beaker. Under the fume hood, 5 milliliters of concentrated nitric acid.
After the reaction, we diluted the solution with 100 milliliters of distilled water to form a light blue solution. The solid copper reacted with nitric acid to produce cupric ions, deadly nitrogen gas, and liquid water.
After measuring 40 milliliters of 3 molar sodium hydroxide, we added it to our copper-containing beaker to produce a cool blue precipitate. We heated and stirred the solution to its boiling point until it changed into a black liquid. Then we let the liquid settle until it became colorless at the top while the precipitate gathered at the bottom. We decanted the top liquid. Then we added 200 milliliters of very hot distilled water and decanted supernatant liquid after cooling again to remove the sodium nitrate from the solution.
Then we added 15 milliliters of 6 molar sulfuric acid, which allowed the copper oxide to react with hydrogen ions to produce cupric ions and water.
Under the fume hood, we added 2 grams of 30 mesh zinc metal slowly to reduce the copper ions to metallic copper and stirred. The zinc reduced the cupric ions to solid copper while reacting with sulfuric acid to produce hydrogen gas.
Next day, we added a little more zinc to the solution to make it colorless.
To remove any remaining zinc, we added 20 milliliters of 6 molar HCl and reacted the solutions in the fume hood. Nothing happened.
We weighed a porcelain dish to the nearest 0.001 grams, giving us a mass of 79.6276 grams.
We added 50 milliliters of H2O to the beaker containing copper and stirred out of the hood. We decanted again and transferred the solid into the weigh dish using water to wash out any parts stuck to the beaker.
We added 10 milliliters of water to the dish and decanted twice.
We washed the solid with 5 milliliters of acetone and decanted the supernatant liquid and discarded it in the organic waste container.
The remaining acetone was evaporated on a hot plate and stirred occasionally. The dry solid was cooled, then weighed, giving a mass of copper of 0.4906 grams.
Percent yield. We calculated which was relatively higher than normal due to a possible mistake or lack of drying the solid product at the end.
We successfally carried out 5 reactions of copper and wrote the balanced net ionic equations for each. We recovered percent of solid copper as a product. An improvement of this lab would be using 2.500 grams of solid zinc the first time instead of adding 2 grams of zinc initially, then more. This would help reduce any potential errors. Overall, this lab was enjoyable and fun.